In the last couple of videos, we've been talking about kinetic energy, where kinetic energy equals 1/2 mass times the velocity squared. Alright. Now, what we weren't talking about was work. Okay? And work is actually defined as joules. So, if you have a specific object, energy is transferred to or from an object as a result of the action of force, which is actually work. Okay? We get joules out of this problem, which is our kinetic energy and our potential energy. But these roll into the concept of work. Okay. Now in our last problem and the previous video, we had our vase. All right, we had our vase, and our vase was roughly 3 kilograms, and it was falling at a height about 4 meters. Now, plugging in all this information, we were able to get our velocity squared. And now that we see that if we increase the mass of the vase, okay, the initial velocity will remain the same, but this equation will increase the work. The amount of work that is done with respect to this problem will be increased. This shows us that the mass and the height at which it falls, okay, the height at which it falls makes all of this linear. So if we increase the mass, the amount of joules and the amount of work is increased as well. If we increase the height, the velocity will change, therefore increasing the amount of joules here. So with that being said, again, work, okay, is energy transferred, transferred, I'm going to write this down, to or from an object, to or from an object as a result of the action of force, as a result of the action of force. Okay. And now the vase, alright, gained kinetic energy from positive work done by the gravitational force of the Earth. Alright, so with that being said, we can actually say that the work of the gravity, okay, is equal to the mass times the gravity, which is negative 9.8, times the initial position minus our height. Okay, I'm going to say y naught minus y, which will end up canceling these two out, giving us a positive work. So just to show that to you, I'm going to get positive work out of this, which equals mass. So I'm going to get 3 times negative 9.8 times y naught, which our initial position from the bottom is 0, minus our height, which is about roughly 4 meters. Okay, 4 meters. And I want to put these in here, and this is kilograms. As you say, if we multiply all this out, we are going to get a positive work, because we have a negative 4 here times a negative 9.8 times 3. 9.8 times 3. It should give us a positive, what we got in our last problem, which is 117.6 joules. Okay, so with that being said, this definition is not restricted to just kinetic energy. So the relationship between work and energy described in this definition, alright, holds in general for different forms of energy besides kinetic energy. So for instance, potential energy, and this work is also considered as mechanical work in connection with energy transfers. So the work, physical as well as mental, that we commonly speak of does not necessarily involve the transfer of energy.